RoboPapa.
Hey guys, the RoboPapa is here. Today's tutorial I'm going to show you how to set up your Raspberry Pi Model B with a Rasbian distribution installed on it. So let's get started. To do that, all you need is the Raspberry Pi, obviously, 32 gig of SD card that you can flash the Rasbian image to, and you will need a couple of softwares. The first one is the Raspbian Debian Wheezy that you can download from raspberrypi.org WAG downloads. Some people using the noobs, but we will just do the Debian Wheezy. You click and you download the zip file. In order to not let you just wait and see how I'm downloading it, I already downloaded it and I unzip it to this folder, and here's the image. We will use it in a moment. In order for us to actually flash that image to an SD card, you will need a software, which is the Win32 Disk Imager, which you can download from sourceforge.net WAG projects, WAG Win32 Disk Imager. And I'll post those links in the description below. After downloading that, you can actually install that disk imager, and you will have something like, can just find that, like so, which is fairly simple. I already have an SD card installed in my machine, and it's sitting on drive F, and I will need to find that imager, which it's under downloads, and it's on the Wheezy Rasbian. You just click on that, then you will just click write, and it will write it. The SD card that I have already is already installed that image. I installed that ahead of time, but it takes around 10 minutes. When you're done writing it, you're actually taking that SD card, putting into the Raspberry Pi, connecting the Raspberry Pi to the Ethernet through either a Wi-Fi, which I don't think you'll be able to work it immediately. So ideally, you want to connect it actually through the cable. So you're connecting the SD card with the cable, a mouse, a keyboard, HDMI cable, because you will need first to set it up with an HDMI cable, and then you connecting the power. The first time that you will load it, you will get the config, the Raspbian config, and it will allow you to set up certain things like SSH or enabling the camera module. I went ahead and did that. That way I can actually use POTI to log in. So I will start it again over here, and I'll show you all those settings. So my Pi is sitting on 64. The end of the IP address is 64. So I'll open it up, and I'm still having the default login. So here I am, logged in over here. So in order for me to get to the Raspbian config, I'll run it right now. And this is basically what you will see on your screen, just a little bit bigger, because I'm still using an SSH over here. And there's certain settings over here that you might want to do or not, like expanding the file system, enabling boot to desktop or scratch. I prefer to boot always to the command line. You can always write start X to, if you need to start it in a, kind of like a Windows interface. So first of all, you want to come here to enable camera and mark it as enable. That way you can immediately be able to use the camera if you have it. I'm not recommending overclocking it because you might burn the chip. And for what most people using it, it's the speed, the 700 megahertz of the processor is good. And Pi. Under advanced options, you can change your host name. if you want to change it. The SSH, that way you can actually go in with PuTTY, like I'm doing right now. You want to enable that. I will go in and like also enable the SPI I2C. I will leave the serial, and if you want to run the update, which I already did as well, you do it from here. So that's the first time that you actually will go in and start your Pi, and that's what you will see. So the system will reboot. So after you actually set up all of those settings, now you will be able to go in with PuTTY. However, as you didn't notice, I don't know what is my IP address, and if it is your case like that, there's a software that you can actually download, and it's called Advanced IP Scanner.com, and what it allows you, it's just like that. It will scan through, and depending on if you change your host name or not, you might see it over here. If you left it as the default, it will just show that as Raspberry Pi, and that's a really nice tool to find your IP address. So I think that my Pi already started. Yep. So I will log in again. And in case you do, you'll remember to check over here before you reboot your IP address. All you need to do is type ifconfig, and you will see your IP address right over here. Alright, so first thing you want to do is go and run the following commands to update and upgrade your software that's already installed in your Raspberry Pi. So you will do sudo apt get update, and it will go and get like all the updates that it needs to. I recommend you to download actually a really nice framework, which is wiringPi, created by Gordon, and he explained over here how to download it, but I'll show it to you as well. And it's a really nice thing to have, because it allows you to manipulate the GPIOs and you know, do certain things with it. In order, the way you actually do that, after you're doing the update and the upgrade, which I didn't do the upgrade, but hopefully it will not take that long, you actually need to install Git. That way you can get the copy of the wiringPi framework. And before you get the Git, you will want to do the update and upgrade as well. So that's why I'm doing it right now. Alright, so we will want to do now is sudo apt get install git core, and that will install the Git, which says that it's already like the newest version. So the next thing that you want to do is git clone git .NET wiringPi. So you want to run this command, and I already did that. So if we look now, you can see right over here I have the wiringPi. So when you go in, you will see that we have build over here. So you want to run that. Oops. And that will start building your wiringPi, which I did it before, so that's why it took a little bit longer. So that's basically the framework. So now we'll run a little example of a blink. So let me get out of this and let's create a folder and let's call it blinker. Obviously CD blinker. I have an editor named Nano, which I prefer. So, and I think it comes with a Rasbian because I didn't need to install it. So I call it nano blink.c. So this is where we write our C code. So the first thing you want to do is actually include the wiringPi.h. That way we have the reference for the wiringPi. So int main void. So every C program starts with the int main. First line that you want to do is we'll do the setup for the wiringPi, and we will declare the mode. And I'm using pin 15 as in the example for the blinking LED. So pin 15, we'll set it up to output. And let's, instead of doing it at infinite, let's actually run it for 15 times. So while count is less than 15, what we will do is let's create a function named blink, and we will pass it the GPIO that we want to use and how many milliseconds we want to wait. And obviously we'll do the count plus plus. So over here we will need to do void blink, and we've declared int port and int delay in milliseconds. And all we need to do really is using the wiringPi functions, which is digital write, and we'll give it the port and we'll say hi, and then we'll use the delay function to delay in milliseconds, which this will basically hold for how many milliseconds we pass, which in this case we pass in half a second or 500 milliseconds. Then to finish the blink, we'll do digital write on the port and low, and once again we will delay with delay in millisecond. Now one more thing that we will need, because it's a C language and the blink comes after the main and we're referencing the blink into main, we need to declare it, to give it a declaration over here. So we'll just do blink, void blink, and it's expecting int and int. Let's see if I can expand this. Alright, so that's basically it. We're setting up the output, the pi setup, declaring the pin output to 15 to be output. We're setting up the count to 0 because we'll just want to count 15 times, and we'll call 15 times, we'll call this blink, which sends the port, which is 15, and how many milliseconds to delay. And this function is really just do write high, wait, write low, wait, and it will do that 15 times. So we'll exit, we'll save into blink, and now we just need to compile this. And to do that, we need to use the JCC. and I wrote this already. Something. All right. So I wrote this. So we doing the JCC with an object. This is the name of the object, is blink. We're compiling blink.c, and we're including the library wiringPi. And as you're getting more and more files, you probably want to make the make file. That way you don't need to repeat this every single time. You just call the make. But for now, it's just like an example, and it's a very simple one. We can just type it. So one thing I forgot to do, because the main is returning an int, it's expecting a return value. So I try that again. There's no errors. So now if I run the blink method, so before we do that, I'll show you the files we have over here in green. It's a blink object that it's actually executable, not WXR, but just the X. So we can run it with the super user. We call it blink, and now the LED is blinking 15 times. And that's basically our hello world in electronics and Raspberry Pi. There's other languages, or basically libraries like OpenCV if you want to use the camera, that you can install, and I'll do that video next of how installing the OpenCV and using it a little bit. So I hope you enjoyed this tutorial, and please subscribe and like, and if you have any comments or questions, please leave it below and I'll try my best to answer it. Thank you guys.